My name's RJ Burnham. I am the founder and CEO of Consig AI, which is a startup focused on building voice AI solutions. I'm going to talk a little bit about the technology and how I've seen it evolve over the last couple decades. Just as background on myself and kind of how to go through it, I have been building voice applications since I was 15. Actually, professionally building them since I was 15. I was one of those crazy young kids that lived in the computer lab. I grew up in the Silicon Valley in California, and we had a Boys and Girls Club. And I would spend every day in the computer lab. They were all Macs, and I managed to learn just about everything you could do about them. One of the cool things that got to play with was they had very early speech recognition. I don't know if any of you are old school Mac geeks back into the 80s. Any hands? Okay, good. I was starting to be afraid I was getting too old. But there was this old technology called Macintalk. And you could use and program in the old Mac's speech recognition. It had very early text-to-speech. Apple was actually one of the very first folks that was invested in speech technology around it, along with a few of the other research groups. I saw that and I just got intrigued. That's what drove me into this universe. I'll play a little clip because I think it's a little bit of fun, just to kind of be a reminder. This is from 1986, old school Star Trek. And no, it's not. We're not going to do it because we have the wrong audio device. So we'll skip over that because in all demos, you'd be ready to go with a backup plan. So as history, I've been working professionally. Like I worked in my first speech recognition professional app was actually to build a app to let you manage your stock portfolio for Charles Schwab. It was terrible. It did not work very well. This was in the 90s, so the speech recognition was in the early days. But these were the projects that started feeding into it. After kind of in that space, I moved into building communications networks. I was the CTO and founder of a company called Voxeo. We built a lot of what they call the communication platform as a service technology and standards. Twilio really came out of the work that we ended up doing and starting with. They did a better job of executing. We got about 250,000 developers on our platform. They ultimately got millions. I have to say, great job. But one of the cool things that we built was WebRTC. We were one of the co-authors and first developers of WebRTC back when it got started, and that went into Cisco as part of WebEx. After a number of years of this, I gave up and said, I do not want anything to do with telecom, with voice. I'm burnt out. I've done this too many years. And I went to this crazy world of computer vision and neural networks because I thought that was a nice, safe escape. Joke was on me. Over the next 7 years, it just converged the worlds of neural networks, which became AI. Transformers came out, and I remember my head of research showed me that, and I was like, you really, do I have to get back into voice? I don't want to do this. Finally, I ended up saying, this is inevitable. I started seeing the applications. I saw the research papers on large language models, and in 2022 started building the first agentic voice platform. This was long before, we started building it before ChatGPT had come out. We were using the original APIs and an early version of LangChain before it was like 0.1 versions of it. Built that. I joke that was a little too quick because that exited very quickly and got acquired by a contact center company. And after that, I kind of said, listen, I've never actually started a company from scratch on my own. I've come very early. I've built a lot of stuff, but why don't I go ahead and start doing it myself? Personally, married, celebrated 10 years with the love of my life yesterday, which was a great chance. I have 4 kids, 2 that live in the US, 2 that live with me here, 3 dogs. And as I said, I grew up in Silicon Valley, spent 15 years in Orlando before coming here to Lisbon 4 years ago. And I travel way too much, both personally and professionally. So let's talk a little bit about why voice matters. Some people say, we hardly make phone calls anymore in a lot of folks. The voice calls have fallen off. But it's the first way we learn to communicate. Yes, we do, there's babies, but it's the most pervasive way we communicate as kids. When we have complicated interactions, we like to go to voice. You start, chat works great, but it works for what I'll call low complexity, low bandwidth interactions. When you get into complicated stuff, you want to be able to explain it face to face, and it really is the scale and it's the way that's really the most efficient for communicating. It's been held back for years because the technology wasn't good enough to actually work. Voice recognition, transcription, Siri was a joke. It was kind of you played with it, but it didn't actually do anything serious. We are on the cusp where that is changing. I think you can use it for very serious applications today. What you can do now is amazing compared to what I lived most of my life in. And the work is just starting. There's a lot of stuff coming down the pipe right now with the next generation research that's going to make it even better. Speed, I actually find it interesting. Vibe coding has got an interesting piece. I actually think that's going to have a lot of work plugged into voice. Programmers, you always think of them as just sitting there typing on their keyboards. I actually think we're going to change that interface a little bit to be much more dialogue. I already find myself, when I'm coding now using AI, I spend a lot of time transcribing it and saying doing a brain dump of what I want, and then having the AI go and build off of that. And really, it is a universal access. It works very well across pieces. I think it's worth noting that this technology isn't new. Everyone talks about AI just in the last couple of years, but it's really built on decades of work in early language. A lot of stuff came out of Bell Labs in the US, a lot of the DARPA applications to fund the early speech recognition, which goes all the way back to the 50s, 60s, 70s. Really, the 80s and 90s is where you started to actually see it commercially used. Dragon Speech Recognizer was one of the first sort of dictation engines that people used. Apple had their command and control engine around it. The first applications were very limited because you really had to train it on your voice. It was in a very small domain. It had tons of errors. And I call it a little bit specialty, but it was the foundation around that on us. Now, the interesting thing is the technology, a lot of it is still the same. It's just evolved. It's gone through iterations. It's gone through tuning. It's gone through data stuff. In the 90s and 2000s is when we really started to see it actually work in the field. The only problem is for larger scale applications, let's say it was American Express, Delta Airlines, British Airlines, they would deploy it, but they would probably spend $10 million on it to deploy it to make it work at a joke level. People still got very frustrated with it. It still didn't go through it, but it was the foundation. I say these early trials led the foundation of what all was going through it. Around 2015, 2017, we got to see some final breakthroughs where the cost dropped probably an order of magnitude. We could start seeing high 6 digits, low 7 digit deployments of it. Still a lot of money. That's a big investment for people to put into it, but that starts putting the tails. And I think right now we're in the cusp where it really can start to go more mainstream, more applications, and we'll talk about that. I think it's worth, and the clicker's not going to cooperate, so we'll just go ahead and go old school. There's a lot of technology that we put into this bucket of voice AI, and that covers this bucket we call language models. There's 3 fundamental pieces I say that come into this. There's speech generation, how you generate, this is where the companies like 11 Labs and Google and Microsoft building synthesized speech engines. This has been around for a long time. The old engines go through it. They sounded very robotic. It would talk like this and did not sound natural. Over the last several years, and especially in the last 2 years, it's gotten so good that if I was building a system, I see no reason to do pre-recorded audio. There's really no reason to do it because the synthesized audio is going to be as good and it's more flexible. Now, this is a big change. It's still incredibly expensive. It actually prices itself out of a lot of applications where you can be truly dynamic, but that's going to change. This is also a big piece, I think, from a technology is we are at a rapid place where the price is shifting. The dynamics are going to be what's out of price right now is going to be available in 2 years. Text-to-speech is that one first bucket. The next round of what go through is speech recognition. And taking that audio from the sound of voice and the audio files into text. And this is the way most systems today work, is they go from speech to a text stream of what was going into it. So when you feed it into a system, and then you're under the covers, you're almost always working natively with text. We'll talk about some changes that have come along with that. But within this bucket, there's actually a lot of different technologies at play. There's speech detection. It's actually very, very difficult to figure out when someone is starting and stopping talking. Even for humans, we struggle with this. Think of the times on a conference call or a phone call you talk over each other. And this is one of the critical technologies to actually making voice AI as a domain work well. These are built on language models. The old school ways of doing this was just using energy and listening, looking for voice energy and having it drop. Well, that doesn't tie into the way we understand if someone goes silent, it depends on the context of what they're saying. If I'm answering a yes/no question and I say yes, you can immediately move on. If I'm speaking my credit card number and I say 4121, that pause, we naturally know is going to be longer. And the language models can learn those pieces, but this is a new domain that needs to be built out. The actual speech-to-text process is another portion. This finally had a breakthrough, I guess 3 years ago when OpenAI finally released Whisper. For years, there had been lots of work done on it, but nobody had ever open sourced a large domain engine. And there had been open source engines, but they didn't have the data to go with it, and they weren't really all that great. OpenAI released this, like I said, it's probably 3 years ago, and it really changed the game for how speech recognition changed. After that, we finally started seeing not just Whisper-based systems, but a lot of other systems be able to get better because they were able to learn, they were able to use the data sets and make it much more capable. There's other use cases within that domain of recognition that are a little bit less common. Verification is this, if you listen to my voice, can you determine that it really is RJ? And then picking out my voice out of a crowd is, we've got all the speakers, we will need to identify what each person. Those are also things that our brains have developed as part of speech input and speech recognition that fall into this domain. And some of these are okay, some of them are still very early, some have a long ways to go around it to really make some of the applications. That third domain is the understanding and being able to take action on this and whether taking that text input and figuring out what did the person actually say. And this, for a long time, was built with grammars. You actually had to go and list every single thing a person would say. That was a very difficult piece. Someone would say something that we didn't predict. Thankfully, large language models fundamentally changed how this worked, and that was the big breakthrough that I think enables a lot of this. But there's still some of these technologies that come into play in real commercial systems when they get deployed, because it's not always just using generative models. So I'm going to take a second and talk through a few of the domains, because some of this is relevant. And for the first long time that everyone worked in speech recognition, we worked with what was called directed dialogue. This is where we do one question at a time, and it's kind of like like the menu installer, where you had to answer one question, and you might be able to go back, but usually you couldn't, and you certainly couldn't go back 3 steps. This is what I'll say still 95% of voice systems and self-service systems are still built using this because it's relatively understood. The tools are built around this paradigm. But it's frankly a bad paradigm for a lot of things. Not everything. If I'm asking to do a payment with a credit card number, that's actually a great application for directed dialogue. Because I'm going to ask you for your credit card number, your expiration date, and your verification code in that order. And we all know how that is. There's not a lot of back and forth. But if I go to, I want to schedule an appointment with somebody, This domain doesn't, that type of task doesn't fit in directed dialogue at all. Because people say all sorts of things. They start with a day, they go back to the hour, they're all over the place. And directed dialogue, people couldn't solve that with directed dialogue. You could, but it was horrible, horrible interfaces. But this is still what most people think of when they've interacted with voice systems, unfortunately. Around 2017, 15 to 17, we finally had a breakthrough on this, which was the deployment of intent-based systems. And you no longer had to build and define every sort of utterance in the framework of what someone said. You could actually train on 10,000 utterances of what recordings and say, this is what most flows go through. And this worked a lot better. This was much more resilient. This is how Amazon Alexa, Siri, those types of systems were built using this intent-based system. It did have a small language model behind the scenes that was built on, that was trained and gone through it. It still wasn't great, but it was a giant step forward, and this really brought what I'll call that first order of magnitude change to the world of speech inputs. We saw a lot of conversational AI companies get started in that 2015 to 2000 era that were built on this framework. And it moved the ball forward, but then unfortunately the rug got pulled underneath them when large language models came out, because it fundamentally changed the way you had to build. This still had a lot of challenges. What you would do in this framework is you would first do speech recognition to convert from audio to words. And then you do what's called NLU, or natural language understanding, to try and build the semantic meaning of what each of those portions. If it was just a simple intent, yes, no, I want to buy a car, that was one layer of easy. But then if you wanted to say, I want to order a pepperoni pizza with pineapple, those two slots falling into it became much more difficult to build, and you would have to train a model with all of those different variations around it. The big breakthrough, of course, though, was large language models and now deploying agentic technologies. The way the new systems are getting built today is everything is in flux. I gave a talk on this back last June, and it is amazing how much of the world has shifted just in that few months. Most of the systems today still work on voice in, convert to text, hand it to a large language model as text, and then go back and convert the text response back to speech using synthesis. I'll say majority of the tech platforms out there are built on that design today. This has worked very well. The nice thing is there's a lot of overlap, for example, with chatbots. If you're building a chatbot or a chat-based interface, that architecture actually lines up very much the same. And there's been some really good developer tools that have come out over the last year. Companies like Vapi, folks like Twilio starting going through it. People are starting to build and create frameworks so that developers can build solutions on it. It's still a lot of change in the industry. It hasn't set around it. There's still a lot of problems that need to be solved, but this puts it into the same domain that people building chat-based AI applications are sitting in as well. You can build that in an agentic manner. You can build it without agentic technologies around it. It really depends on what type of tasks that you're needing to go with it. The biggest challenge, though, in voice is latency. This is probably one of the biggest challenges and what holds a lot of things back and why there's still a lot of limitations. There's been a lot of work to bring in smarter models that are more capable to do reasoning, to do thinking. That works great in a chat interface where you can also sort of see that it's thinking and doing stuff. When it's over the phone or over a WebRTC call, those delays start to become very, very problematic. So there's a lot of techniques and tricks you try and do to sort of compose small, fast language models that can be handling the responsiveness, and then bigger, complicated models that are doing reasoning and tasks around it. So it becomes a big orchestration task to plug all these together. I don't think this is a solved problem for the developer experience yet. There's a lot of ideas, there's a lot of frameworks, there's people trying to go through it, but I honestly don't think we've, as an industry, figured out how to do it in the optimal way. I think we're still several years from this kind of truly being figured out, partially because the game is changing pretty rapidly. The way OpenAI does it is different from how Google does it versus how you would do it in a LangChain ecosystem versus how you do in VAPI or Rasa. These are all different folks making techniques around it, and there isn't one right answer, and it's going to take a lot of experimentation. The fun part, though, I think also in here, and this gets into what I think is frankly not solved well yet today, is all the stuff that goes beyond just the chat and the dialogue and speech recognition. The barge-in and voice activity detection and understanding when someone has started and stopped speaking needs to get better. As good as OpenAI's advanced voice mode kind of was, it's still frankly terrible. It gets confused all the time listening to background noises, interruptions. It jumps in too early when I haven't finished talking. This is still a domain that needs to be improved drastically. That's not really different, but the thing is, it's now become the weak link. For years, the speech recognition wasn't very good, so the fact that if the start and stop wasn't great, it was okay because it kind of got masked by the limitations of the rest of the system. Now, frankly, this is kind of that front gate and is what makes good experiences or bad experiences on that. Lots of tricks on this. This is very tricky. This is where it gets very resource intensive. You want to be ideally have something that's very lightweight and can run as close to the edge of the device as possible so that you can get sort of maximized performance, because this is once again one of those things that if it's slow, causes trouble. This comes back to my next piece of latency. Most applications, frankly, the models today are still too slow to be completely natural. You know when you're speaking to one of these systems because there's still a delay. People are working hard to bring that down. It really needs to get down all the way to, I think, below 300 milliseconds. From what I've seen, under a second is pretty doable, and it's actually very usable. But we really need to keep bringing it down end to end to make this feel more natural around it. The other piece that comes into this is how it also responds with the tone of voice. There's been you see some of this in voice in advanced voice mode. You see some of this in some of the new models that got released, like Sesame, which is a speech generation model. Being sensitive to expressiveness, emotion, how you actually are going to respond to the person. Do you have a professional calm demeanor, or are you joking and laughing, or are you frustrated and crying? Those elements are going to be still needing to be solved to make these interfaces fully natural around it. And I don't think it's solved. I think we're still a few years from solving it, but people ignored this whole domain for years, and finally now it's getting some attention. One of the things I mentioned, though, that I think's coming right now and is in the process of making a bit of a disruption around this is the next generation of AI models don't actually end up working on text for these types of interfaces. They take an audio stream in, and they generate audio right back as effectively a native audio to audio pipeline. This reduces latency. It makes it more responsive. It unfortunately breaks the model that like most people have built their platforms on, where you have access to the text and you can control and you can take actions based upon the text actions. It's still also extremely expensive compared to the alternate ways, but this is what's going to, I think, how systems are going to get built of tomorrow. It's going to take some re-architecture, especially a lot of the enterprise systems are going to have to be retooled to work natively in this type of platform, because it does change the domain when you no longer have text at the core. You might get a transcript afterwards, but that doesn't actually line up to how the model took actions, how you go through. Question?
Yeah, technical question. How do you see those unified transformers possible? What's going to be a token? Is it going to be a phoneme? But how a phoneme can transfer tone context or
It,
emotion?
it does that. So because it's also effectively, when you start training these on audio itself, it does start to pick up those properties. So we can actually tell the difference between an angry yes and a sad yes on there. Those ultimately will get learned into the training set. So it comes down to data. This is the great beast of all of these things, is you need to train it on enough data to make it good enough. But we will start seeing that it opens up the option to that type of response, because what it does is it learns that it should generate different audio back, because we're no longer dealing with text, we're no longer directly dealing with even phonemes, we're dealing with internal LLM concepts and tokens, which I could have a separate talk about how, you know, it's not really non-deterministic, it's just that we don't understand the math anymore in our heads around it. But they're fundamentally building responses, and it's no longer just a word, but it's actually how the audio is generated on this. There's hybrids of this. It's not just all straight audio. People have been doing work to just bind together the speech recognition and the language LLM portion of it, and then leave the synthesis on there so it can fit into a better pipeline more like this. There's a lot of different ideas, and this is kind of a very quick moving area. I haven't seen anyone take a huge lead, but there's some cool projects like Ultravox, which is actually where they take the speech recognition and bind it to like a llama LLM for understanding, and then you can stream tokens out as text to go and build speech synthesis. That actually works. It addresses a lot of the latency problems, but then doesn't break the architecture, because you still ultimately have text. It just collapses two portions of it. This is, to me, the fun part that I think is going to get interesting to watch. Who can build this? OpenAI's got some great models available today. Google's got some really great models on this today. It's making its way through everything, but it's still got portions to go. As a startup engineer trying to build a company in this space, frankly, some days it's overwhelming. And because you sit there and you say, how do I keep up? Well, the fun part and the painful part in all of this is, as cool as all this AI side is, there's a lot of ugly, terrible plumbing to actually hook it up in the real world to applications. If you want to deploy this into a telephone network, there's a lot of things you have to actually make work around integrating into cell phone networks, integrating into regular voice networks. How do you deal with the constrained audio bandwidth that comes across? The quality on a phone call is far worse than if you do it over a web stream. How do you scale all this? As soon as you connect it to the telephone in the real world, now we get into crazy regulatory rules, which are a completely separate domain than what exists in the internet world. And there's a lot of inside problems. I'll use the example in the US. If you want to deploy an AI voice agent over the telephone, there's one set of rules if you're doing inbound calls. It's a completely different universe if you're doing outbound calls. It puts you in a different bucket of regulations. Throughout Europe, every country is a mix mash of all these pieces. And this, to me, is actually where some of the, as a startup founder, where some of the value can be done. I don't need to necessarily compete on core AI models, but I can integrate the best of those things and have the understanding of this, unfortunately, obscure, complicated pieces around it. Where we've also looked at is doing outbound as opposed to inbound. We all know outbound calls are full, usually spam, and it's not a good thing, but there's a lot of good applications for AI in proactive outreach. Medical care is a huge one. These are whole domains of people where we don't call people after a doctor's appointment to make sure that are they actually following instructions. If you're doing in-home care, there's almost never any data collected from the patient to say, was it a good experience, was it not? If the person's not there on site to collect it in person, it doesn't get captured. And this is a whole domain where actually, to me, I get the most excited about, because frankly, my meta feeling is companies are really bad at communicating with me about stuff that's going on. And I want them to be more proactive about letting me what's going on without being spammy. And this is the domain that I think is interesting to kind of build around through this. And that's the little niche we at Consig are focusing about, is how do we build outbound outreach applications, whether it's for healthcare, appointment reminders, changing doctor's appointments, scheduling, payments, any of the things where a company needs to have somebody call you, but they probably don't. How do we automate and make that a better experience, both for the customers and for the companies on that side? So I do want to take a second and talk about where I see things going next, because I think while there's a lot of voice that has started to come through, I think we are at a stage where there's a lot of changes coming down the road next. And the way I would in my opinion, in the digital domain, voice, AI, agents, and technology is inevitable. In the next 3 years, anytime we call a company or when a company calls us, 80% of the time it is going to be a generative AI agent, probably taking that first round of interaction. I don't know what platform is going to win that, which technology is going to win it, but I believe in the digital domain, it is inevitable that AI agents will take over the bulk of customer communication. Is it 3 years? Is it 5 years? These are where a lot of companies are going to be made and grown and scaled and fail in this domain, but it is happening. To me, the interesting place, though, is what comes next. And I think we're at the breakthrough that if I put my 5-year hat on, my 10-year hat on, I actually think we may actually be at the spot where we can start deploying voice into real-world applications. What does that mean? Being able to have it work on an airport check-in counter, having it work in restaurant environments, having it work in theme parks and hospitality. Finally giving us the Star Trek experience of just being able to say computer. Now, is the technology there yet? Absolutely not. We have noisy backgrounds, we have speaker isolation, we have accents, we have kids interrupting, asking, you're trying to order one thing and go, this is all heavily unsolved problems, but if I put my 10-year hat on, my 5-year hat on, I think they're coming up next, because I think this is finally a stage where it's possible. Before it was just science fiction. Now when you look at what's starting to come down the pipe, it's going to get there. And to me, this is where I get interested in what can we start building around this in these types of experiences. We've been working with a partner that worked with in the US that does spatial audio, thinking about how we build next generation AI natural language experiences. The environments I kind of go with is, imagine you're at Disney and all the signs know who you are and can interact with you and make recommendations and you can ask questions about based upon just talking to it. That they can communicate with your kids and just go through it, and they know what your ride preferences are and can make the suggestions or where the long waits are. Within a museum, being able to ask questions about an exhibit. Right now we get our phones out, but a lot of times it's like, well, what does that do? Voice is a great interface for those types of pieces, and I think, my opinion, this is what is possible. It's not ready for today, but this is the fun stuff that frankly brought me back to speech for tomorrow. I'll kind of drop there because I think I've used most of my time. In fact, I'm a little bit over, and I'm going to skip doing demos just because we'll go through it. But I really did want to say thank you. I'd love to open it up for questions if we've got a few minutes to go through it.
One demo.
One demo? All right, let's do one demo. So let's see. So this is our core platform in here. So this is set up for managing outbound campaigns, managing outreach to customers. We're going to use this in a hospitality and healthcare setting, and we're going to have it trigger a phone call here. Normally this would be, of course, linked into a booking system, but let's see if it works. And I probably should have taken off Do Not Disturb. Hold on, because it didn't go here. Let's try this again. the need to actually take the call on the phone. We're going to trigger one more phone call since it went to the wrong device. Hello?
Hi, RJ. This is Vicky at Ocean View Hotel. How are you today?
Doing great.
That's wonderful to hear. I'm delighted to let you know your room, number 412, Ulmer, our coastal king, is fully ready for you. Can I get you checked in?
Sure.
Perfect. Before you arrive, can I confirm your contact details? I have your phone as 831-555-1234 and your email as rj@rjburnham.com. Is that still correct?
Let's use my work email of rj@consig.ai.
I apologize, but I encountered an error. Let me transfer you to a representative who can assist you further.
All right. Throws on there, but demos are always fun. So. Shall we open for questions if we've got a few moments?
Yeah, we can do 3 or 4 questions.
Hello, thank you very much. I have 3 questions corresponding to 3 dreams. The first one is when we are speaking in such audience, when we are not in the conference but after, there is so much noise that it's difficult to speak, to hear, to understand. So we are, it's necessary to speak more louder, and then it's tiring for anyone. So would there be a solution for this, to have something in the ear, to avoid the noise that is surrounding, and only speaking with the people that are around you? This is the first question, the first dream. The second dream is to translate very quickly when I speak in English. I would like to have something in my ear, speaking exactly what is said in another language directly. Not necessarily translating words, but translating the intents. And I was seeing, when I was seeing your table, I was seeing speech to text, text to speech, and I was introducing between the translation options. So speech to text, text translation, then new text to speech, but perhaps there is a solution to do quicker speech to speech. And the third dream is probably a remind from the film, I think it's The Fifth Element, when Lilou, you know probably this film from a French guy, and she is meeting the hero who is a man who is healed now, and she is putting a video DVD to learn what is the situation, or to see the wars on the planets and so on. So I had the idea, the question at the time. So assuming there is a robot looking at the story, the robot is looking and hearing the film, and then he is understanding and grasping the story and having to enhance his knowledge about the history. But my question is, if you take the file of the DVD without looking at what is the content of the file, the decoding in video and audio, should it be possible to understand directly from the file?
All right, you gave me 3 fun ones, so I'll try and tackle them as quick as I can. I actually think the speaker isolation, which is what you kind of talked about, of being able to zoom in on one person's speech and focus on that and drown out the rest. I actually think that's probably the furthest off of the things you said, but I do believe that it's really, really critical for use in speech in the real world. That being able to just talk to a voice assistant and have it pick up and identify one speaker out of it. The base technology exists and people have been going through it, but it's not good enough yet. And I'd say that feels to me like the furthest out of those elements. But it's definitely possible, and I think we will go through it. I actually think it needs, I think it does depend on multi-channel and spatial audio to make this work well. We have 2 ears, and that lets us identify the stream a lot better in our brain, as well as our eyes. It's actually somewhat of a multimodal problem that if we're looking at the speaker, we can follow it usually better than if we're not have our eyes on it, because we sync up the visual inputs of the mouth, ties into a whole experience. I think we're a ways off, but I think that's solvable, but it's still not there. Real-time translation is coming and coming very, very quick. I've seen prototypes, I've used some prototypes. It's not going to be seamless as we would like to as the universal translator, because sentence structure is very different between different languages. If you take a look at comparing how Japanese and English is structured, you get completely different order of the sentence, and you can't translate words, and you have to do it in sentence chunks to have that meaning-based as opposed to just stream of words. So I think that's going to work better. I've seen demos of it. I've played with some of it that is very impressive and not far off. I think the applications of making it universal are still a ways, because fundamentally there's that time delay that even the best translator in the world has to let someone get all the way through it. But I think we will see that soon. And you're right, the answer is to actually go native, basically bake the translation in the model, and that's what some of the new models that are in the research place are doing. Your last one of being able to consume directly from the file and codec, no reason you can't. It's just that comes down to training data. I believe we'll see, I believe that gets into the world of optimization of a lot of these pieces, because right now the answer is you would decode it, stream it, feed it in the visual domain. There's a lot of work being done to do shortcuts in computation, and that's one of the shortcuts that people look at is, can you do it on the codec data? Yeah, can you do it on the codec file natively in there?
How do you deal with the errors, namely when you are saying, for instance, email addresses, numbers? It's very tricky, especially email address is terrible, because you can have a 4, it might be a number 4, might be the word 4, might be a 4 without a U. You may have words that sound similar. If you don't have a context, that's terrible.
So,
any way, for instance, combining this with the user having a visualization of what is being said, because it's terrible being communicating something that is.
So this is definitely an area that is tricky, and speech recognition is not perfect, nor will it ever be perfect. Humans make mistakes, and we misunderstand things just as well. Context is a big thing that makes this a lot better. In fact, how we solve speech recognition, a lot of the speech recognition error rates, is actually bringing in the language context and what other information you have about the person. So let's use my company name, Consig. Speech recognitions, a lot of time, get that as config. Well, it's actually this is an area where LLMs are really, really powerful, because if they know they're speaking to RJ, founder of Consig, it will often be able to identify that mistake and correct, even if the speech recognition screwed it up, the language level can correct it and ask about it to confirm it. So I've done some exact demos with that exact flow where you give something that's a little bit ambiguous and you get a speech recognition error, but you can pick it up with context. And context is the key to all of this. The other thing is we build our agents that if it's in these cases on something like an email address, read it out letter by letter. It's the same way you would actually talk to somebody in a call center. They're going to make sure that they actually understood it. You can still actually speak to them however you want. You don't have to give it to them letter by letter, but you do a confirmation letter by letter or on the tricky parts where there's opportunity for mistakes. So I kind of look at it as it's a little bit of prompting and a little bit of, like, it really comes all down to context and being able to leverage whatever you have and introduce it in ways you can't. Okay.
It's going to be very quick. Thank you first for your presentation. It was really good. It's a little bit boring question, but if I'm thinking in putting one model in front of any human, I'm thinking in one race. So how should I keep my model safe for any question that the human can ask and keep it, focused on the task?
I missed a little part of the question. Could you say? I want to make sure.
One race. So how would you care the model is not giving any crazy answer to the customer, or is it's not advising something that shouldn't because language is so big and we can find race.
So it depends a little bit on the domain and what the sensitivity is around the type of mistakes. First thing to remember, humans make mistakes too, and machines are not going to be any better. In fact, actually, in some of the cases, they're more reliable, I believe. To address what you specifically go through, a lot of times what we do is we'll build supervisor models that are watching the communication. Now, this can introduce latency. This can slow portions down. But if you're doing something important, it's the double check your work. So in most of our systems, there's not one model at play. There's multiple models engaging and doing different portions of the task, and they kick in and kick out depending on where you're into it. A lot of what we've seen as the most successful ways of making it work in the real world is using contextually appropriate models that can kind of shift in and out behind the scenes.